Half adder is a digital circuit in electronics that is used to add two bits or two binary numbers, which means two inputs, and give sum and carry as a result, which means two output. The logic diagram of half adder consists of an AND gate and a XOR gate, which is exclusive OR gate. As we know, while adding two binary numbers, we get a sum S and carry, commonly known as C out. We can use AND gate to get the carry out and OR gate to get the sum. Now a question arises here is why exclusive OR gate is used to generate the sum. Let's discuss the working of exclusive OR gate. Exclusive OR gate means it gives 1 when the inputs are different and gives 0 if the inputs are same, and this is the same case in sum of 2 bits, so we can use XOR gate to generate sum. Now why AND gate is used to generate carry? This is because AND gate gives only 1 if both the inputs are 1. Similar is the case in addition of two binary numbers. The Cout will only 1 if both the inputs are 1. Now let's discuss the inside of an IC. Either it is an AND or XOR gate IC. Both have almost similar structure from inside, except they have their respective gates, which means an AND gate IC consists of AND gates and XOR IC must contain XOR gates. The point to notice is that each IC has a VCC and a ground. VCC stands for voltage at common collector, which means it supplies all the necessary power to the IC, while ground is a reference point for measuring voltages. Now let's construct a half adder on a breadboard, but on a virtual breadboard. Is it work the same as the real breadboard? Yes, exactly. It is well-designed software called as Tinkercad, in which you can design circuits as well as display their results. To make a virtual breadboard, sign in to tinkercad.com and create a new circuit. Now a new empty circuit project has been opened. So first of all, what we have to do is to write here breadboard and drag and drop the breadboard up to our project. First of all, there is a need to understand about the connections in the breadboard. You can see the connection from the breadboard is from this point to this point and from this point to this point, which means you connect a wire here, you can extract the connection from here, and you connect a wire here, you can connect the extraction from here and also from in this line. Similarly, these all lines are arranged in a manner like that, which means you connect a wire here, you can extract the connection from here. Similarly, for all these lines, the connection is vertical, and for these 1 2 3 4 lines, the connection is horizontal. So we need an AND gate IC in order to see the carry. So let's pick from here the quad AND gate IC and drag and drop it here, put it on circuit breadboard like that. Now we also need an XOR gate IC, exclusive OR gate IC, also put it here. So as previously I mentioned the connection, now you can see this is the ground. So first of all, what is in internal of IC? Let's see it. This is pin number 1, this is pin number 2. So how can we distinguish these pins? We can see there is a small cut marker here, and there is also a white point up here. If we put this point to the left, to my left, then the pin here is the pin number 1, and next is pin number 2, and up to here it is pin number 7, and above that is pin number 8, and up to here is pin number 14. So pin number 1 and pin number 2 are the inputs and pin number 3 is the output. Pin number 4 and 5 are the inputs and pin number 6 are the output, and pin number 7 is ground, which is used to connect the negative terminal. So what is ground? Ground is a negative, is a connection or reference point. Ground is a reference point from which we measure voltages. Now let's connect the ground wires to the negative terminal here, right here. We later on connect this to the negative terminal of the battery. Also XOR gate IC, and we also have to connect the positive terminal to the power supply or VCC. This 14 number pin is called VCC, voltage at common collector or power supply. Now when we have connected this to the positive line light here, right here, later on we connect this to the cell or battery. Now let's connect it. As we know, both the inputs A and B are connected to both OR gate and AND gate ICs. So let's connect this line to this line and this line to these lines, which means now if we apply any wire to this line, any logic level to this line and this line, this will also apply to here and here, which means if we apply any logic level to AND gate IC, it will also apply to OR gate IC. Let's change the color here, yellow, and let it extract the output from here and here. We extract the output from here to here, so we can connect the resistors easily here and connect the LEDs to it. Let's find out resistor. This is resistor. Put it, drag and drop it here. It's very large. Recommended voltage is 220 ohm or 200 ohm for half adder. Let's arrange these lines correctly. Add another resistor here. We are adding the resistor in order to protect any damage to LEDs. Let's connect an LED over here. So this tool is used to rotate any object, and this tool is used to rotate, invert any object. The wire which is the LED pin which is bent is positive terminal, so we have to connect it to the resistor, copy it and paste it over here, and we have to connect the straight line or pin which is the negative terminal to the ground. Now our circuit is complete. All we have need is a battery, which is 3 volt battery. We can use any battery below 5 volts. So here is a positive terminal and there is a negative terminal. Pick a different color and connect it to the VCC. This line has all the connection and these connections are going to VCC. So we say this line, we can say this line as VCC, and connect also this to this, which is negative terminal, which is grounded. Now these blue lines are the logic level. Basically these are not the voltages. We are applying the logic levels to the pin number A and pin number B. They are logic levels at the beginning but when we apply it to the pins in it, the AND gate IC, it becomes logic level, and from the output the logic levels are extracted, converted into voltage, and then the LEDs light up. So in this way it works. Let's connect the positive one to the positive and another to negative. So it is expected that the sum is 1 because 0 plus 1 is 1. Delete this. Now add both to positive. Now it is expected that carry is 1 and sum is 0, but there is a little problem here because we have connected the wire wrong here. So let's correct this. Basically the mistake is we have connected the line to the input number 4, not to the output, which is pin number 3. So connect it right here and run. It works. Now connect both to the ground and run. The sum is 0 and the carry is also 0.